Hey guys, welcome back to another video. In this video, we're going to look at the rest of the questions for complex numbers. So the first question, question 11, is on a sketch of an Argand diagram, shade the region whose points represent complex numbers z satisfying the inequalities of z plus 2 is less than 2, modulus of z plus 2 is less than 2, and the imaginary value of z is greater than 1. Therefore, if we have to directly draw a circle where the radius is 2, why? Because they're telling you that the complex number z and the complex number 2 plus 0 iot is going to be having a distance of 2 or less than 2. Therefore, we are directly going to draw a circle with center minus 2. Why? Because you're going to take minus common, z minus 2 minus 0 and this is going to be your expression for the circle. So you know the center is going to be minus 2 minus 0 or 0 minus 2 0. So this is minus 2 0 and the radius is supposed to be 2 or less than 2. So you draw the circle with circumference this and make sure that the radius is supposed to be 2. Once you're done with that, you have done with the inequality 1. The second one is telling you that the imaginary part of the equation is supposed to be greater than 1. What does this mean? This is basically telling you that the y coordinate, meaning if x plus iy or yi is the expression for a complex number, the y value or the y coordinate or the coordinate on the y-axis is always supposed to be what? Greater than 1. So in that case, you draw a line y is equals to 1, this one, y is equals to 1, and say that the values of z will lie in this area. You shade that area. Why? Because z can only be inside this circle and it also has to have a coefficient of greater than 1 for the imaginary value. Great. So you shade this part. Okay, that is question 11a. Now for b, what are they telling you? They're asking you to find the greatest value for argument of z for points in the shaded region. So argument of z is basically telling you that what angle is the complex number z making with the x-axis. This is x-axis or the real axis. So what angle or theta is z going to be making with the real axis, and in which case will the theta be the largest? They're asking for the greatest value. So if you want to find out from this shaded region at which point is the complex number z going to give you the greatest value, it is going to be over here. Why? Because at that point the angle made is going to be this, where the angle is the greatest. If you take any other point, be it here or be it here, the theta is going to be less than this green line. So in that case, we now know that z has to lie in this point to get the greatest argument, meaning the greatest theta. So how do we find out the coordinate at that point? We have two expressions or two equations. One is for the circle. For the circle, you can write it as, since the centered is minus 2 and 0, you can write the equation as x plus 2 whole square plus y square is equals to 2 square, where 2 is the radius. Now you also know that the point is intersected by y is equals to 1. If that is known to you, you put in the value of y is equals to 1 and then find an equation, a quadratic equation, and solve it to get values of x. You will get two values of x. Why? Because y is equals to 1 line intersects the circle at 2 points, this point and this point. So you're going to get take the greater negative value, which is for this point. Great. So the x coordinate for this point, or the complex number, which is the real coordinate. So the real coordinate of the complex number is what? Minus 3.7. So z is going to be given by minus 3.7 and plus I. Right. So you now know the expression or the value of the complex number z, which is going to give you the greatest argument. If that is known to you, now you can try and solve for the theta. Why do you need theta? You need theta to find out this argument, arg of, what is it called, z. Why? Because arg z is going to be pi minus theta. So if you know that, let's calculate theta first. Tan theta is going to be opposite, which is 1, by adjacent, which is 3.7. so theta comes out to be 0.264. so argument z is going to be pi minus 0.264, which is 2.88 rad. Great. So arg z is 2.88 rad. Okay, let's move on to next question, which is question 12. Right, for question 12, they're asking you to solve the quadratic equation 1 minus 3i z square minus 2 plus I z plus I is equals to 0. Now, giving your answers in the form x plus iy, where x and y are real. This is worth 6 marks, so it's very lengthy. And yeah, it is lengthy. So you have to use the quadratic equation, which is minus b plus minus root over b square minus 4ac by 2a. What do? You simply plug in the values of b, a, c, a. Right. So if you plug in all the values, you're going to get an expression of z, which is one is positive and the other is, one is going to be this, the other is going to be this. After you rationalize it, you're going to get this and this. So if you go step by step, first of all, we're plugging in the value of 2 plus I in b, and the minus signs get cancelled off. And for b square, we're plugging in the value of b directly, and then we have 4 minus 4 times a, which is 1 minus 3i, then we have c, which is I. So after you simplify inside, you're going to see it comes out to be 2 plus I plus minus 4 plus 4i minus 1 minus 4i minus 12. The 4i gets cancelled out, and in the denominator you're going to have 2 minus 6i. After everything gets cancelled out, you're going to see 4 minus 12i is going to give you a value of minus 9. Now minus 9, if you try to solve this, is going to be 9 times of minus 1. Now you can write 3 times root over minus 1, which is 3i. So I have directly plugged in 3i. Now if you do know that, if you've come across this expression, now what do you need to do? You need to write one expression as 2 plus 4i, the other is going to be 2 minus 2i. Why? It's either going to be 2 plus I plus 3i or 2 plus I minus 3i, where you're getting minus 2 or positive 4i. So there are two expressions for z, which is going to give you the roots of z. This is first root, this is the second root. Right, now you have 2 plus 4i by 2 minus 6i. If you want to rationalize this and remove the complex number from the denominator, what do? You multiply the denominator and numerator with the conjugate of the denominator. So 1 minus 3i gets multiplied with 1 plus 3i in both denominator and numerator. Right, so if you do that, you're going to get minus 5 plus 5i by 10, and if you break the fraction, you're going to get minus half plus positive half of I. In this case, you're going to do the same thing. You're multiplying the numerator and denominator with 1 plus 3i. Now you're getting an expression of 2 by 5. It's supposed to be 2 by 5, right? 2 by 5 plus 1 by 5i. Exactly. These are going to be the two roots of the expression of this quadratic equation, and this is worth 6 marks. Okay, now we can move on to the next question. Basically, in this question, you just apply the quadratic equation, nothing else. Alright, for question 13, what do you do? For question 13, they're telling you the complex numbers u and v are defined by u is equals to minus 4 plus 2i and v is equals to 3 plus i. Great. So they're telling you find u by v in the form x plus iy, where x and y are real. Right. So for this, first let's write down the expression for u and v. U is minus 4 plus 2i, v is 3 plus i. So if you try to write it in a fraction, u by v, you get minus 4 plus 2i divided by 3 plus i, and again, to rationalize, to remove the complex number from the denominator, what are we doing? We are multiplying with the conjugate complex number, which is 3 minus I. Right. After we do that, we are going to get minus 1 plus I as the complex number. This is the complex number for u by v. Right. Now, yeah, that's exactly what they wanted. So A is done. A is done. Next to B, hence express u by v in the form r e I theta. So this is basically another form of expressing x plus iy. This is basically another form of expressing x plus iy. So how do we do that? R is the modulus or the distance, and theta is the argument. Theta is the argument. So we first find out the r, which is the distance. So for r, we're taking root over 1 plus 1. Why? Because this is a value of 1, and in front of the I there is 1 as well. So this can be expressed as this triangle, where on the x-axis it moves by 1 and on the y-axis it moves by 1. So this value is going to be given by 1 plus 1 under a root. We are basically using the Pythagoras theorem. So we have received a value of root 2 as the magnitude, or u by v mod. This can also be written as u by v mod. Anyways, so we now know the value of r. So we now know the value of this. Great. Now let's find out theta. What is theta? Theta is basically if this is the complex number, if this is the complex number on the Argand diagram, theta is going to be, not the argument, the theta is going to be this, which is going to be tan inverse of 1 and 1, opposite by adjacent. So tan inverse of 1 by 1 is going to give you 45 degrees or pi by 4. Once you have that, you now know theta. So what is the argument? Argument is going to be 180 minus theta, or 180 minus pi by 4, or sorry, pi by 2, sorry, pi minus pi by 4, which is 180 minus 45 degrees. So now you will have the argument of z. Great. The other way to do that is 90 plus 45 degrees, or 90, sorry, pi by 2 plus pi by 4, whichever you do, you're going to get the same answer. So the argument of u by v is 3/4 of a pi. Great. So you now know the argument and also the modulus. If you know both of those, you can now plug it into r e I theta, where r is root 2, theta is, or the argument rather, is 3 pi by 4. So you get the expression root 2 e to the power I times 3 pi by 4. That is your complex number in exponential form. Right. So you've answered B as well. Now they're telling you in an Argand diagram with origin O, the points A, B, C represent the complex numbers u, v and 2u plus v respectively. Great. State fully the geometrical relationship between OA and BC. So first of all, let's write down the new term 2u plus v. What was u? Minus 4 plus 2i. This was u. And multiply with 2 and add v, which was 3 plus I. So the new complex number we get is minus 5 plus 5i. This is the new complex number. So we have to plot all of u, v and c, which is actually 2u plus v, 2u plus v, and the origin O. Great. So after you plot all of those, you're going to see that the shape that arrives is actually a trapezium. Now that is not what they're asking you to answer. What they're asking you to answer is state fully the geometrical relationship, not the shape, between OA and BC. So how do you answer this? So since this is of 2 marks, there are 2 statements that you are going to write. First of all, notice that both the line OA and BC have the same theta value or has the same slope, meaning they are both parallel. If they are both parallel, you can say OA and BC are parallel. This is the first mark. The second mark comes where you're going to notice that OA is going to have the half length of BC. How do you figure that out? This is taking 4 boxes. This is taking 1, 2, 3, 4, 5, 6, 7, 8. This is taking 8 boxes. So the length of OA and BC is going to be in a relationship where BC is double of OA. 2 OA lengths is going to give you 1 BC length. So this is another relationship. So that is answering question C. Okay, now for D, what are they telling you? Prove that angle AOB is 3 by 4 or 3/4 of a pi. Now, they're telling you angle AOB is 3/4 of a pi. How do you figure out angle AOB? What is angle AOB? This, right? So for angle AOB, notice you will have to minus the argument of B, which is this theta, from the argument of A, which is this big theta. So argument of U, which is A, minus argument of B, which is V, is going to give you this small theta in between. So if you remember that argument of any 2 complex numbers which are divided, let's say u by v, can be written as argument of u minus argument of v. So if that is the case and it is written as argument of u minus argument of v, this can also be written as argument of u divided by argument of v. I've explained how this works in the other video, where basically let's say R1 is one modulus, the modulus of one complex number, and R2 is the modulus of another random complex number, and e to the power I 2 pi, or let's say pi, is the argument. This is the argument of this complex number, and e to the power I of 3 pi is the, not 3 pi, 3 by 4 pi is the argument of another complex number. I can rather write this as 2 by 6 pi, or 1/3 of a pi, right? 1/3 of a pi. So in this case, what is the difference between the theta of these 2 complex numbers? This is one complex number, this is another complex number. So what is the difference between their theta? So if you draw it on an Argand diagram, you're going to notice that one is going to have an angle of pi. So this is going to be an angle of this, and where it's making 180 degrees, and the other is going to make an angle of around this. This is going to be angle of this, whereas this is the angle of this. So if you divide both of these, notice that pi minus, you have to follow the indices rule, and r1 by r2 remains as it is, and e to the power becomes, take I common, and pi minus 1/3 of pi. So what are you doing? You're subtracting both of those angles. What are you doing? You're subtracting both of those angles in this case. So what are you getting? You're getting this argument. You're getting the difference between both of those arguments, which is this. So basically, whenever you're dividing two complex numbers, their arguments get subtracted, which is why you can say if argument of u minus argument of v is to be found, you can plug in the value of argument of u by v, which we already found out over here. We already found that out, which is 3/4 of a pi. Therefore, argument of this, I mean AOB, is also 3/4 of a pi. Alright, question 14. What are they telling? Solve the equation z square minus 2pi z minus q is 0, where p and q are real constant, meaning they are not imaginary values. So solve this equation. Basically, this is the same thing as before, where you use the quadratic formula, which is minus b plus minus root over b square minus 4ac divided by 2a, and you're basically going to plug in the values of b, a and c, which are the coefficients. So plug in the value of b, which is 2 pi I, and then under the root you plug in the values of b square, a and c. So after you do that, after you simplify everything, by the way, you have to take 4 common over here, so that you can take the root of 4, which is going to be 2, and the 2 comes out over here, and now you can take 2 common from everywhere. So you're taking 2 pi I plus minus 1 root over q minus p square by 2. So this 2 and this 2 gets cancelled out. So you are left with this expression, which is pi plus minus root over q minus p square. So from this, since there is a plus minus, you are going to get 2 answers. So one is pi plus q minus p square, and the other is pi minus root over q minus p square. These are the 2 roots of what equation? This equation. So you're basically using b square minus 4ac. You can take your time and try to understand the steps, but I'll move on to the next question for now. The B is asking you, there's another information. In an Argand diagram with origin O, the roots of this equation are represented by distinct points A and B. Great. Given that A and B lie on the imaginary axis, find a relationship between P and Q. So they're telling you that on an Argand diagram, both the imaginary or complex numbers are going to lie on the imaginary axis. So z1, which is one of the root, and z2, which is the other root, both of these, the question is telling you that are going to lie on the imaginary axis. So let's say this is z1 and this is z2, right? So in this case, they're telling you both must be on the imaginary axis, meaning there should not be, if z is equals to x plus iy, there should not be any real part of the expression. X is supposed to be 0. Therefore, this means that if we try to go step by step, the discriminant must be negative, so that both points can lie on the I axis or the y axis. This is I and this is x. Now, what does that even mean? Basically, you know that both of these, this and this, is imaginary. Now, if let's say both of these parts are giving you a positive value, in that case you're going to be left with a root over positive value. Now this is a real value. After taking the root of the positive value, you're going to get a real value. However, if q minus p square or the discriminant is negative, this is going to give you imaginary value. So if it does give you imaginary value, then only then this condition is met, that the points are going to lie on the y-axis. Why? Because if q minus p square is negative, this is going to give you another let's say xi or bi, pi plus bi. B is unknown, I'm just giving an arbitrary value. So you're getting another imaginary value. So there is no real part to this equation. There is 0x, meaning there is no real part to this expression. This means that indeed the point will lie on the y-axis. So for the condition to be met, q minus p square, the discriminant has to be negative. Has to be what? Negative. Has to be negative. So let's analyze for all the situation. If discriminant is 0, what happens then? Both points are going to be the same. Why? Because pi plus root over 0, meaning 0, and pi minus root over 0 or minus 0 is the same as pi and pi. So z1 and z2 are not different. So this does not stand. Therefore, if we look into the next condition, if discriminant is positive, what happens? What happens is you're going to get root over positive value, which is a real value. So the equation or the expression is going to have a positive or a real part. In that case, either this point will shift to this side or to this side. Therefore, it cannot have a positive discriminant, because in that case this z value will shift to this side or this side. You don't know that, but the question is asking you to put the z value or the complex number on the y-axis. So in that case, discriminant has to be negative for it to be able to lie on the y-axis. So if the discriminant is negative, what does that mean? That means that p square has to have a greater value than q. For example, q is 5 and p square, let's say 3 square, is going to give you 5 minus 9. Therefore minus 4. Now this is a negative discriminant. So we know p square has to be greater than q for there to be a negative discriminant. So we can say p square is greater than q. So this is how you answer question B, that p square has to be greater than q. Great. If you know that, now we can move to the next question, which is C. So what is C telling? Given instead that triangle OAB is equilateral, express q in terms of p. So basically they're telling you that if these are the two complex numbers, these are going to be giving you an equilateral triangle. Basically it's going to have 60 degrees at all corners. So therefore you know from these two expressions that the coefficient of I, meaning the y values, are the same. So what does that mean? It's going to lie on the same line. So if you know that, and it's going to be positive most likely or negative, so you can draw it like this as well, no problem, but I've drawn on the positive axis. Anyways, so you know both of these points are on the same level, and now the question is it going to be plus or minus? Depending on that, you plot on the negative axis or on the positive axis of the x-axis. So therefore, since inside the value is the same, q minus p square, they're going to be equally away from the y-axis because they are the same expression. So granted, this is z1 and this is this is z1 and this is z2. Now they're telling you prove that all of these thetas, or that the entire triangle is actually an equilateral triangle and all the angles are supposed to have 60 degrees. So if you know that, to prove that, we can do something simple, which is if you take this very triangle, you should know that if I draw it again, this is supposed to be 60 degrees, since if this entire theta is 60, this half theta is 30. So if this is 30, this angle is supposed to be 90 minus 30, 60. Great. So if this is 60 and you know the height, which is p. Why? Because pi. So p. And what is the distance on this axis? It's going to be root over this real part, which is root over q minus p square. So this is root over q minus p square. Right. So now you can say tan theta or tan 60 is p over root over q minus p square, right? Now you know the value of tan 60, which is plus minus root 3, plus minus because over here tan is positive, over here tan is negative. So plus minus root 3. Now you can take square on either side and remove the plus minus and the roots. So you get 3 is equals to p square by q minus p square. Now you can make q the subject and you get the expression for q. This is exactly what they wanted. They said express q in terms of p. So we have expressed q in terms of p. Great. So that is question 14. Okay. Question 15. What are they saying? On a sketch of an Argand diagram, shade the region whose points represent complex numbers z satisfying the inequalities modulus of z plus 1 minus I is less than 1. Argument of z minus 1 is always less than 3/4 of a pi. Great. So since you know this, let's take the minus common 1. So what is the center? Minus 1 and I. So quickly plot the center. This is the center. And what is the radius? Radius is supposed to be less than or equal to 1. So take less than or equal to 1 and draw the circle, meaning take the radius as 1 and draw the circle. So now you know this is 1, minus 1, and this is positive 1. Great. So now you have the circle. What is the next inequality? They're telling you z minus 1, or rather z minus 1 plus 0i. So what is this point? This point is on the x-axis, right? On the x-axis and 1 away from the center or the origin, sorry. Now if this is the point, they're telling you the angle subtended by z and this complex number is going to give you 3/4 of a pi. So this is 3/4 of a pi. So you draw a line, and see that since they're telling you less than or equal to 3/4 of a pi, it has to be on this side. Since in this side it is greater than 3/4 of a pi, right? It is greater than 3/4 of a pi. This is 45 degree and this is 90 degrees. So the total is 3/4 of a pi, or 135 degrees, I guess. So yeah, you draw this line and shade this small area, which is representing the values, or the values of z, the complex numbers z. The complex numbers can lie in this small area to satisfy both of these inequalities. Great. That is question 15. Oh my god. Okay. So question 16. What are they telling you? Verify that minus 1 plus root 2i is a root of the equation z to the power 4 plus 3z to the power 2 plus 2z plus 12. This is basically a simple way to do this. Some people might plug in the value of this directly inside the z, and find the answer, because they're going to see that if, let's say, plug in -1 plus root 2i and to the power 4 and so on and so forth, you're going to see after you solve the entire thing you're going to get 0, but that is very lengthy. So the easier way to do is, since you know one of the root, which is -1 plus 2 root plus root I, the other is supposed to be -1 minus root 2i. So if you know both of these roots, you should also know the factors, which is x minus the root and x minus another root, and if you multiply both of these you get a quadratic equation. This quadratic equation is a factor of the entire equation, is a quadratic factor of the entire equation. So if you multiply, I have used a square minus b square formula, and I've received an expression of x square plus 2x plus 3. So don't use x, because since the equation is in terms of z, use z instead over here, but I've used x by mistake. So yeah, use z and you're going to get z square plus 2z plus 3, right? So by the way, if you're confused about how I used a square minus b square, basically this entire part is a plus b multiplied with a minus b, since a square minus b square is represented by a plus b times a minus b. I could apply this formula and factorize, right? Sorry, not factorize, simplify, right? So that is how I used the formula, and I've received a value, expression for x square plus 2x plus 3. Now what do? We'll use long division and prove that if I do divide this for this, you will have a remainder of 0. That is the proof that this is indeed a factor of this. So if this is a factor of this big equation, this must have been the root of this equation, because the factor is coming from the root, right? So what do? We directly use long division, and we've gotten a quotient of z square minus 2z plus 4. So after the division you get a 0, and proof, this is shown. So now you know that x square plus 2x plus 3 is indeed a factor of this equation, right? So you can look at the long division and let me know if you have any confusion. So yeah, I'll move on to the next part. B, what are they telling you? Find the other two roots of this equation. So it's much more simple now. Basically you know the roots for this part, which is -1 plus root 2i and -1 minus root 2i. So you don't need to solve for this. This is known and this is unknown, so solve for that. Again, use b minus b plus minus square root of b square minus 4ac divided by 2a, and you're going to get one is 1 plus root 3i, the other is 1 minus root 3i. So use this, plug it into your calculator, just show this step. This is what they care about, that you're using b square minus 4ac formula, and then you can directly go to this step where you're if you, after plugging into your calculator, you should get this both expression. So you will do once for plus and once for minus. So that is how you solve for question 16. Now off to the next question. This is awfully lengthy. Okay, question 17. The complex number 1 plus 2i is denoted by u. The polynomial 2x cubed plus ax squared plus 4x plus b 4x plus b, where a and b are real constants, is denoted by p of x. It is given that u is a root of the equation p of x is equals to 0, meaning that u, which is 1 plus 2i, is a root of the main equation. So if you know that, they're asking you for 17a, find the values of a and b. What do? This is unnecessarily lengthy, so basically I'm not going to go over the steps. This is very long. You just have to calculate and simplify, nothing else. You plug in the value of 1 plus 2i or 1 minus 2i, but you have to plug in 1 plus 2i since the question is asking you for this. So don't plug in the conjugate expression. Plug in the real, I mean the main complex number. So after you plug in the complex number 1 plus 2i, you're going to see that after simplifying everything, let's come to this step and understand what's happening. You take the real parts on one side of the equation. What do? You take the real parts on one side of the equation. This is the real part, and you take the imaginary part on another side of the equation and take I common, right? Now all of this is equal to 0. Why? Because you've plugged in a root of the equation, and if you plug in the root of the equation into the main equation, you're always supposed to get a remainder of 0. So we have written 0, and you can express this as 0 plus 0i, because 0 doesn't have any value, so you can write that. So after you take all the real values on one side and the imaginary values on another side, you can say this is equals to this and this is equals to this. So after you do that and you simplify, minus 18 minus 3a plus b is equals to 0. This is one equation. The other is 4 plus 4a is equals to 0. This is another equation. So now you have a is equals to minus 1. Plug that in over here and you get b is equals to 15. So you get the answer for both of the quotients. Okay, so this is how you do question A, which is very long. You basically have to sit down, take a deep breath and do all the steps one by one. Right, so next we have B. State a second complex root of this question. Very simple, I've already done this. U conjugate is going to be 1 minus 2i. 1 minus 2i. Great. What is question C? Find the real factors of P of x. What do? You know these are the two roots. So you already know these two roots are available to you. Now there are also going to be another root which is unknown, which is going to be real. Since this is a polynomial to the degree of 3, there are going to be 3 roots. 2 are known and the other one you don't know. How do you solve this? You take x minus one of the root, x minus another root, the conjugate pairs, right? So once you do that, again you use a square minus b square and simplify, and I'm considering this as a, and this as b, this as b, and in the middle you can see once there is minus and the other time there is a positive sign. So you can use a square minus b square, and after you do that, you see you get an expression of this. This is the quadratic expression where the roots are complex numbers. So this quadratic we already know. Now this is the main equation, main EQ. So you divide the main equation by the quadratic factor and you get a linear factor, which is 2x plus 3. After you do the long division, this is the entire process, you have a remainder of 0 and a factor of 2x plus 3 and x square minus 2x plus 5. So the factor is 2x plus 3. Great. So that is C. D is asking you to sketch on an Argand diagram, shape the region whose points represent complex number z satisfying the inequality z minus u, meaning the distance between z minus u is always less than root over 5 and argument of z is always less than 1/4 of a pi. Great. So how do we do this? You know one of the point which is u. So they're telling you this is the inequality for distance, where modulus of z minus u is basically the distance between z and u. Where is u? U is basically over here, plus 1 and plus 2. Great. Now the distance between z, which can be anywhere on this Argand diagram, the distance between z and u is supposed to be less than or equal to root 5. So the radius is what? Root 5. Great. So you draw a circle with center 1 and 2 and radius root 5. After you do that, they are also giving you another inequality where the argument of z, meaning if z lies anywhere inside this circle, that z should make an angle of less than or equal to 1/4 of a pi. So you draw 1/4 of a pi, which is 45 degrees from the center, since This is argument of z, only z. So argument of z is going to be calculated from center, from the center. So this is pi by 4. So z can lie anywhere in this part and in this part. Why in the lower part? Why over here as well? Because you see, if let's say z is over here, is the argument less than pi by 4? Yes, it is. How? Because this is negative. Under the x-axis, the arguments are negative, so they are indeed less than pi by 4. So you shade this entire area. Great. So that is how you get 1 d1. And next you have 2. What is 2? Find the least value of imaginary part of z for points in the shaded region. Give your answer in an exact form. So basically they're telling you that the imaginary part of the expression of complex number is going to be the least. They want you to find out when is the imaginary value the least. So when is it least? Over here. So how do you find that? You know this length, which is 2, since from 2i, so this is 2, and you know the radius. What is the radius? The radius is actually root 5. So 2 minus root 5 gives you this, which is the least distance, of z. Alright, question 18. What are they saying? Given the complex number u is equals to a plus ib and w is equals to c plus id, where a, b, c and d are real, prove that u plus w conjugate is equals to u conjugate plus w conjugate. So how do you prove this? You know what is u? You know u, which is a plus ib. You write a plus ib. You know w, which is c plus id. Now keep the conjugate as it is. You're going to change it into the conjugate later on. So now you take the real parts on one side, the imaginary parts on the other side, and take I common, right? So now you have a plus c plus b plus d I. So after you change it into the conjugate pair, you add a negative sign. Since the purpose of a complex number is basically just adding or changing the positive into a negative. That is it. So now you have answered the question, partly, as you have shown the conjugate value of u plus w as a plus c minus b plus di whole multiplied to I. This is the expression that you're supposed to get after you expand this as well. So what is the conjugate of u? A minus ib. Since there is a plus ib, you change the plus to negative, and a minus ib. What is the conjugate of w? C minus id. Now after you take real to the one side and imaginary to another, you get the same thing as this. This is how you prove A. Now for B, what are they asking? They're telling you solve the equation z plus 2 plus I conjugate plus 2 plus I z is equals to 0, giving your answer in the form x plus iy, where x and y are real. Great. So you take the conjugate of z plus 2 plus I. How? Break down z into x plus iy, and you take the real to one side and the imaginary to another side, and keep the conjugate as it is as of now. And then what do? You do the same for the z over here. You break that z down into x plus iy. Great. After you do that, you multiply, simplify, and take the real to one side, which is 2x plus, this is supposed to become real eventually, over here, and you take the real to one side and you take the imaginary. After you change this conjugate plus to minus and you remove the conjugate, now you have this. So after simplifying, you're taking the real to one side, taking the imaginary to one side. That is the whole point of simplifying this from the beginning to the end. The idea should be, after breaking everything down, you take real to one side, and the imaginary to another side. That is the whole objective. Why? Because you will be comparing the coefficient. You will be comparing the coefficient of what? Of 0. Meaning, since 0 is on the right hand side and this is entirely, sorry, I'll highlight this and this. Since no, yeah, it was right. So since the real part is over here and the imaginary part is over here, you can say, you can break this 0 down into a real part, which is 0 still, and 0i as the imaginary part. Now you can compare the coefficient. Now you can compare the coefficient. This is the real part is equals to 0. 0. This is the imaginary part is equal to 0. You compare the coefficient. Now you have two equations. 1, 2. So from the beginning, what did we do? We broke it down into this, separated the real and imaginary part, then changed into conjugate pair. Then for this, we simplified, we got this, and then finally we paired up all the real parts into this and paired all the imaginary parts into this. That is the whole point of this simplification. Great. After you receive two equations, 1 and 2, what do? You're basically going to substitute the value of y into over here, and after you do that, you get x is equals to minus 1 by 4. Plug that over here and you get y is equals to 5 by 4. They asked you giving your answer in the form x plus iy. So they wanted to know what is the value for z. What is the value for z? Since this is a linear equation, there is no power, there is only going to be one answer for z, or the complex number after you solve it. So this is your final answer, where this is the real part and this is the imaginary part. I hope I could explain how we compared the coefficients and found the final answer, z. This is the complex number. Great. So now let's move on to the last question, question 19. This is basically telling you the complex number of minus root 3 plus I is denoted by u. Express u in the form of r e to the power I theta, where r is supposed to be greater than 0 and theta is supposed to be between negative pi and pi, giving exact values of r and theta. Great. So if u is minus root 3 plus I, it's easy. Find the modulus or the distance. How do you do that? If, let's say, this is minus root 3 and this is 1i, so let's write it as 1. What is r? R is the root of square of root 3, which is 3, and square of 1, which is 1. So now you get 2. So r is supposed to be 2. How do you find the argument? First find out the theta, which is this. So tan opposite, meaning tan theta is equals to opposite, which is 1, divided by adjacent, which is root 3. Now you get theta. Now this is not your argument. Your argument is supposed to be this much, which is pi minus theta, right? So pi minus pi by 6, you get the argument, which is 5 pi by 6. So this is your final answer, This is your final answer, where 2e to the power I 5 pi by 6. That is your answer. Now for B, what are they telling you? Hence, show that u to the power 6 is real and state its value. So they're telling you, you use this form of complex number, and they're telling you that this entire thing to the power of 6 is actually real. How do you prove that? So if you break it down, the 6 and 6 gets cancelled out and you're left with this. 2 to the power of 6 is 64. Now you have to do something tricky over here. This is arguably one of the tricky questions that I've found out. Some are pretty lengthy and complicated, but this is actually a bit, you need good concept to understand this. So what you do over here is you change this form. They've asked you, is it real? So to prove that, what do? You don't keep the complex number in this form. You change the form of the complex number into r cos theta plus sin theta. I hope you remember this form of complex number. You change this into this form. Why? I'll show it in a minute. So after you change it, what is r? You've already found out r, which is 2 to the power of 6, which is 64, multiplied by cos of 5 pi, since this is the theta, plus sine of 5 pi, since this is indeed the theta. Now you know cos of 5 pi is actually minus 1 and sine of 5 pi is actually 0. There is supposed to be an I over here. Anyways, so since sine of 5 pi is 0, 0 times I is still 0. So actually you're getting a value of minus 64. You're getting a value of minus 64. Since this is actually real, you can say that u to the power of 6 is real. And this is the value. Great. So you've answered question B. And question C, what is it saying? On a sketch of an argand diagram, shade the region whose points represent complex number z, satisfying the inequalities. Argument of z minus u is between 0 and 1/4 of a pi. Great. So argument of z minus u is between 0 and 1/4 of a pi. So what does this mean? Z minus u is basically telling you that this difference of coordinates is supposed to make a theta between 0 and pi by 4. So let's plot the known value of complex number, which is u. You do know the coordinates of u. What is the coordinate of u? Minus root 3 plus I. So let's plot minus root 3 plus I. This is u. This is what is known to you. Now they're telling you that the argument, meaning z minus u argument, basically they're telling you that z can be anywhere on this argand diagram, granted that it makes a theta between 0 to pi by 4 with u. So that is what this expression is telling you, right? So in that case, you draw the point, the coordinate u, and draw an angle pi by 4, and draw a line over here, and draw a line over here, and this up till infinity is the shaded area where z can lie, because it's going to make an angle between 0 and pi by 4. But they've also given another inequality where they're saying the real part of z, meaning that the real part of z is supposed to be always less than 2. So if z is equals to x plus iy, this x value is supposed to be always less than or equal to 2. So what do? You draw a line x is equals to 2 over here and shade the region less than this, which is this entire area. So you have met two conditions, which is the theta made by u and z should always be between 0 and pi by 4. The other condition is that the real part of the complex number r is equals to z is equals to x plus iy. This real part should always be less than 2. So you draw a line over here and shade this triangle. Great. Now off to the last part 2. Find the greatest value of z modulus for points in the shaded region. Give your answer correct to 3 significant figure. Now they're telling you, what does z modulus mean? Z modulus means the distance between origin and z. Origin and z. The magnitude of distance between origin and z. So they're asking you, if z lies anywhere on this triangle, shaded region I mean, where is the greatest magnitude of z modulus? Where is it the greatest? Obviously at this topmost point, since this is the greatest distance from origin. So how do you find the, what are they asking? Greatest value of distance. So how do you find this distance? It's pretty simple. The way to do this is actually First, let's draw the triangle of the shaded region. This, you know, this theta is pi by 4. This theta is also pi by 4. It's slightly tricky, so I'll give a star. So this theta is pi by 4 and this theta is pi by 4. If that's the case, you know this is an isosceles triangle. So you know this length, which is 2 plus root 3. 2 plus root 3. So this length is supposed to be 2 plus root 3 as well. So this is 2 plus root 3. What is this length? 1. So you now know, if I draw this triangle, the longer triangle, you know this length, 2 plus root 3 plus 1. And you also know this side, which is 2. Great. So if you know that, you just need to find out this area. Theta doesn't matter because they want to know the magnitude of the distance. So now use Pythagoras theorem, and modulus of z is going to be given by root of 2 square, and 2 plus 1 plus root 3. So 3 plus root 3 whole square. You solve and get a value of 5.14, and that is the greatest distance of z mod. That is it. All right, see you in the next video.